Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Summit Academy. In this video, we're doing the interim number 2, meaning the end of the trimester review. So we're going to be practicing for this second interim. I'm going to break it up across 2 videos, so that way you have enough time to kind of space it out. I'll be explaining stuff, so even if you don't have enough workspace, you maybe get it out on another sheet of paper, so that way you can write some notes down. That way you can have it. Okay. So in this part, it says select each rational number. So that we have to be able to break apart what it means to be rational and what it means to be not rational. So again, rational means it can be a fraction, a over b, with b not equal to 0. Again, a and b are integers, or it could be the decimal form, either ends or repeats. That just means like the decimal, like 3.12. See how this ends? It stops right there. It doesn't keep going. It doesn't have the decimals after it or anything like that. Or you could say repeats. You could say or repeats would be like 3.3 with that little bar over it. Or you could say 3.333 and it goes on like that. And then you could say things that are not rational are going to be called irrational. Again, this means not rational. What they look like is this. Again, they're not going to be a fraction because they're not rational. We're going to say that the decimal form either, or let's say like this. Decimal form must not end, and it has to do both, must not repeat. So notice how, just the opposite of what it means to be rational. So if it does both of these, then it's going to be not rational. If it does one of them, it's going to be rational. Or if it's a fraction, it's going to be rational. So what we're going to do is we're going to circle each of the rational numbers for the situation. So square root of 3, that's going to be an irrational number, so we're going to say that's not what we're looking for. The second one, notice how it has the bar over it. That's going to be rational because it repeats. 1/4 is rational because if you look at the decimal ends, or you could say it's a fraction. So that one's good. Negative 3.62. That one's also good because the decimal ends. We're going to say this one is irrational because it does not end and it does not repeat. And square root of 16 is equal to 4. So we're going to say that is going to be rational as well because it ends. So always make sure you're looking at the results. Again, if you need to pull up that Desmos calculator, so give me 1 second while I have that up. About this one. There we go. So if you're looking to do that square root of 3, again, make sure in the bottom left you click that keypad button. You're going to say square root button is right here. Say square root of 3. And I look at this decimal, notice how it keeps going and there's no end or repeating value to it. However, if I do square root of 16, notice how it's just equal to 4, and so that one's good. And again, even though it looks like it cuts off right here, it would keep going because there's more decimals after it, so just make sure that you're not thinking that it stops. Okay. So let me hide that real quick. Moving on to the next one. For number 2, it says, which point best indicates the location of the square root of 39 on the number line below? So make sure, just like we did before, you can say, I can find that square root of 39 and look at that decimal. So let's say SQRT of 39, it's going to be about 6.24. So what we can say is on our graph, we can say, square root of 39 is going to be about 6.24. So if I was to place 6.24 on the graph, again, I would say, well, it's not going to be A or B because those are clearly not by 6. But if I look at this one, I could say, well, D I can't do because it's below 6. So that one is less than 6. And so we're going to say that point C is going to be our approximate location for the square root of 39. So let me make sure that's on there, like that. Okay. Moving on to number 3, it says, what is the value of the square root of 49 divided by 81? So instead of having to divide, so make sure when you rewrite it, what you can do is like this. I can say square root of the entire fraction, 49 over 81, is going to be the same as the square root of 49 divided by the square root of 81. That way you can take each of these individually. Each of these are going to be perfect squares, so I can find the square root of 49 is going to be equal to 7, and the square root of 81 is going to be equal to 9. So our choice out of here is going to be 7 over 9. So be sure to separate the square root symbol, meaning I'm talking about this step right here. So make sure that you're separating like that, so that way it's in the numerator and denominator. And a separate note too, make sure that you're understanding the difference between a square root and something squared. So when we say square root of a number, just remember that that is going to be your answer. So let me write it like this. Let's say answer will be a smaller number. When you are talking about the square of a number, so squaring a number will give you a larger number. So just make sure that you're seeing the differences between these two. So if I was to write an example down of square root, again, square root of x looks like that, where x squared looks like this. So make sure that you're saying how these two are different. Even though they look like the same wording and they sound similar, they are very different actions. All right, moving on to the next one. For number 4, it says find the solutions to the equation x squared equals 14 and select each correct answer. So make sure you're saying, again, when it says each, that usually means more than 1. And again, that's also, you could also see it with the s in the parentheses. That usually means there could be more than 1. So when you take the square root of both sides, so I'm going to say x squared equals 14. That just means I have to take the square root. So I'm going to take let's do it like this. Inverse operation is to take the square root. So this is the inverse operation. And we're going to say that when we take that square root, it's not going to just be a decimal, because that's none of the answers. But what we could say is this. We have to say it's not only going to be positive 14, we have to say and negative 14, because it gives you 2 possible answers. And the reason why this works is if you looked at negative 14 squared, that's like negative 14 times negative 14, that equals let me do it like this. If you were to have, so let me back up a second here. If you were to take negative square root of 14. So that's what it's going to be, sorry. Forgot the square root. There we go. So if you take that squared, that would be equal to positive 14, and also the positive square root of 14 squared is going to be equal to 14. So since these two numbers are the same, we're going to say that our answer for this, our answers, plural, is going to be the negative square root of 14 and the positive square root of 14. So just make sure that you're including both answers. All right, moving on to number 5, it says solve this equation for x. So two ways of doing this. You can use your inverse operations to solve for x, or you can graph it out. So what I would say is this. I would say, so use inverse operations to solve for x, or graph on Desmos. And so that's what I'm going to actually do first here, is I'm going to graph both sides of the equation. So remember, when you go to graph this out, you have to say this is going to be your first equation, so first line, and then we're going to say our second line, so I'm going to do a different color. Let me say our second line is going to be the right side, so this is going to be your second line. So let's graph it out, see what it looks like on our graph. So we're going to say if this is our graph, so we're going to have the left side is going to be 1/2, and what we can do is we can write, let's actually write it out. So let's say y equals 1/2 x minus 7. Remember, you're probably wondering, where did I get that y from? Well, when we go to graph it, we can just write it like that. We can say y equals one side of the equation, and y equals the other side, and we're trying to see where they are equal. So wherever they intersect, they are equivalent. All right, so here's our two lines. Notice how I can find where they intersect, and so I'm going to say this is going to be that point of intersection. So at point 18, 2 is where they are equal, and since we're saying, so what we would say for this one, we would say x is going to be 18 because that solution point is 18, 2. Again, we're looking for solution. Let me hide this real quick. There you go. We're looking for a solution point x, y, which is the same thing as point of intersection. All right, so you could do it like that, or what I will show as well is how to solve it using those inverse operations. So this is very similar to our problem that we had from the Unit 4 test. So what I'm going to do is, first I'm going to multiply both sides by 6. So multiply both sides by 6. The reason why I'm doing that is I want to get rid of this fraction. And so what I can do is I can say, well, 6 times 1/2 x is going to be 3x, and 6 times negative 7 is going to be negative 42. On the right side, I have 1/3 times 6 is going to be 2 times quantity x minus 12. Same thing, make sure you distribute the 2 to each of these terms. So I'm going to say if I need to, I can do it on the side here. So let me actually do like this. So I'd say 2 times x and negative 12. So I have 2x and negative 24. So this is going to be, left side stays the same. Right side is going to be 2x minus 24. Now we need to get the x's on one side, so I'm going to subtract 2x because that is the lower coefficient out of those two options. So I subtract 2x from both sides. My left side is just x minus 42, and my right side is just negative 24. Last step, use those inverse operations, add 42 to both sides, and we get x equals 18. So I always like to show that I can solve either by graphing or by using the inverse operations. That way you can check to make sure that your answer is correct. The reason why I do this is because if you look at number 6, it says this problem is worth 3 points. It says 1 point for the correct answer and 2 points for showing the correct steps in your work. So make sure that you must show work for full credit. Okay, so what we're going to do, it says determine the solution of this equation, so let's go ahead and find this out. We'll check it once we get our answer, but what we can do is this first. So let me switch back. Okay, so what I'm going to do is I'm going to do my distributive property first. So I have -3 on the outside. I have 1x and -1 inside the parentheses. So I have to multiply each of these terms. So -3 times x is going to be -3x, and -3 times -1 is +3. So then I can write that underneath. So I have -3x plus 3 equals 8x plus 7. I have variables on both sides, so I add the opposite to the lower coefficient. So I'm going to add 3x to both sides. And I can say I have on the left side 3, and on the right side 11x plus 7. 2 last steps to get x by itself. Subtract 7 from both sides. I say on the left side I have -4, and on the right side I have 11x. Last step, divide both sides by that coefficient. So I divide both sides by 11. I can say x equals -4 over 11. And I can leave my answer as a fraction. That way, it doesn't have some crazy decimal. But what we can do is check by graphing on Desmos. And so same as the last problem, I'm going to graph out my left side of my equation. So this is going to be my first line, -3 times quantity x minus 1. And my second equation is going to be 8x plus 7. Let's go to Desmos and compare our answers. So let me actually write that answer at the top here. Actually, I'll just graph it out first. Okay, so we're going to say pull up our graph calculator. Let me clear this out. Hit that home button to get back to where you were. Get back to the origin. All right, so left side is going to be y equals -3 times quantity x minus 1. There's one line. And my second line is going to be y equals 8x plus 7. And let's find where they intersect. And I have a negative number, but it doesn't look like -4 over 11. So what went wrong? Well, let's check out what is going to be -4 over 11. If I actually compare those two answers, I'd say, hey, those two are going to be the same because it's -0.363 repeating. And so if it rounded up, so if I did round -363 to the third decimal place, it would be the same answer. So notice how -4 over 11 is the same as -0.364. So just make sure that you can either write the decimal like I have here, or you can keep your answer as the fraction. Either way works out. All right, moving on to number 7. This one, real simple. You should be able to graph it out. And so let's graph it out on our Desmos calculator first, and then we'll show it the other way. So let's clear these out. And we can say, all right, left side is going to be -4 times quantity 5 minus 2x. And we're going to say the right side, this is still y equals. And my second equation, y equals, is -36 plus 4x. Again, if you don't see them intersect or you don't see the values right away, you can zoom out, scroll down if you need to, find where that intersection point is or where they cross. We're going to say, hey, the x value is what we're looking for. So we're going to say, since negative 72 or negative 52 isn't one of the answer choices, that's what y equals anyways. So we're just looking for x. So we're going to say, for this one, we're going to say that x, I'm going to say x equals negative 4. And so let me actually show you as well how this works. So if I wanted to, I can do my distributive property first. So I'm going to multiply each of those terms inside the parentheses by negative 4. So let me draw that out a little bit better. So negative 4 times the quantity, 5, and then a negative 2x. So I have negative 4 times 5 is negative 20, and negative 4 times negative 2x is going to be positive 8x. And so now if I write that underneath, I'm going to say that, okay, this goes down. This is going to be negative 20 plus 8x equals negative 36 plus 4x. Compare those coefficients. I have 8 and 4. Since 4 is the lower one, that's why I'm going to add the opposite to both sides. So I'm going to subtract 4x from both sides. On the left side, I have negative 20. Change that back. I have negative 20 plus 4x equals negative 36. Two last steps. So I add 20 to both sides to get rid of the constant term that's on the variable side. So then I have 4x equals negative 16. And my last step, divide by the coefficient. So I divide both sides by 4. I can say x equals negative 4. So either by graphing or by using those inverse operations, both ways works. And so that way you can get your answer. All right, moving to number 8 on that front side. We're going to say, it says select that the equation that has no solutions. So what does it mean to have no solutions? Well, let's actually look at this real quick. So if we look at the image that I have up here, it tells us what type of information we need. So we're talking about if we have a number of solutions, it either has one solution, no solution, two solutions, which could come up for quadratics, but we don't have to worry about that, or infinitely many. So if it has one solution, it just intersects at one point and they have different slopes. Or if they have no solution, they're going to be the same slope but different y-intercepts. And that just means if I look at this picture, that just means that it's going to be parallel lines. And so what I can do is I can graph out one side at a time. So what I'm going to do is I'm going to say that, hey, I'm going to graph out the left side, I'm going to graph out the right side and see what I get. So let's pull up our Desmos calculator. So give me 1 second. And let's home and clear this out. So I'll graph that left side. I have y equals 8x plus 4x. And I have, sorry, that should be x. And then I have y equals 0. So notice this is going to be just one solution, so it can't be that one. What about the next one? It has 5x plus 1. And I say y equals as well. And the second one is y equals 1 minus 5x. So this is also one solution. So that's not going to be it either. We're looking for no solution. So we're going to say 4x minus 8x minus 3. Say y equals in the front. And we say y equals right side, which is 6 minus 4x. So notice how these two have parallel lines. They don't intersect, so that means they don't have any solution. So we're going to say the third one is going to be the one that we are looking for. So we draw a little star by it. So just remember that we're looking for parallel lines for no solutions. And the last one on the front page, it says how many solutions are there to this equation. So it gives us our system, and so same thing, we're going to graph each side on Desmos and see what we have. So let's pull up our calculator, clear this out. I type in my left side, reading like a sentence from left to right. So 6x plus 9, and I have y equals 3 times the quantity 2x plus 3. And if you notice how as soon as I type in that 3, that's when the other line comes up. So since they're overlapping lines, we're going to say that that is going to be infinite solutions. So we're going to say, just as a reminder, that bottom one, same slope, same y-intercept, we're going to say this is overlapping lines. So that just means that we're going to say this has infinite solutions on this one here. Alright, so I'm going to actually pause here so that way you can break these two apart. So make sure you can rewind, replay, and pause as needed. Ask questions as they come up because we have our test on that Thursday. Be sure to ask questions as they come up, and as always, super slam that subscribe button.